Hello, welcome to UNS classes. Today we are going to discuss about escape velocity, one of the most important topic from gravitation. So you know that, so on the surface of Earth, if you are on the surface of Earth, you are always pulled towards the center of Earth, because of gravitation force. What is gravitation force? When two masses are there, the masses attract each other. That phenomenon is known as gravitation force of attraction. So because of that, all the bodies on the surface of Earth are pulled towards the center of Earth. Now, if you're throwing a ball in the upward direction, you know that it will go in the upward direction for some distance to some distance and will come back to the surface again. Now, you know that we are capable to send satellites into the outer orbits, into the outer space, or we are capable to send, moon mission, or we are able to send some capsules to moon or even to Mars. So how is that possible? How we are able to send this much huge mass, sometimes 4,000 ton, 5,000 ton, objects are projected in the upward direction and it's completely escaping from the gravitation field of attraction. How is that possible? It is possible if you are providing sufficient energy to escape from the gravitation force of attraction or sufficient velocity. We can make it happen, because that much energy if you are providing, we can overcome the attraction. So we are going to see today how to find out that, how to mathematically quantify the velocity required or energy required to send some object from the attraction force of Earth or any planet. So we can do this with the help of simple energy conservation. On the surface of Earth, when a body is resting on the surface of Earth, we can calculate its gravitational potential energy. And when you are projecting, we can find out kinetic energy. See, the total energy is always equal to potential energy plus kinetic energy. You can find out for initial condition and you can find out for final condition. As per conservation of energy, both initial and final should be equal and you can obtain the solution, the expression for escape velocity. Let us see how to do that. Assume that you are on the surface of a planet. See? Okay, this is a planet and this is a body which we are trying to project, maybe a rocket. And you know that the Earth is having a mass m, and assume the radius of Earth is r. Similarly, the mass of the object is small m. Fine. You can find out the gravitational potential energy. What is gravitational potential energy? Gravitational potential energy U is defined as minus of G m by r, since we are on the surface of Earth. Okay. Now, if we are projecting this with a velocity, see, initially if you are projecting a velocity VE, assume that VE, I'm calling it as escape velocity, then you can find out the total kinetic energy. How much is kinetic energy? Kinetic energy is going to be equal to half mVE square. So, the moment we give that much velocity, the total energy of the system is sum of potential energy plus kinetic energy. That is the initial condition. See, the total energy is going to be equal to the sum of the kinetic energy plus potential energy. Let us try this for the initial condition. Let us substitute the values for the initial condition. So look here. So total energy in the initial situation is going to be equal to potential energy. How much is that? G m by r. Fine, potential energy. Then kinetic energy, half mVE square. This is the initial condition. Fine, this is the initial condition. Now, when you are going to outer space, the body is going to stop at some point, because the velocity will keep on reduce as we go in the upward direction and it's come to rest at one point. Fine. That time, velocity goes to 0, so kinetic energy goes to 0. Again, when you are far away from the surface, the R increases. R increases to infinity. It will go to very far away location, or we can say it goes to infinity. It goes to infinity means 1 by infinity. Again, you can see 1 by infinity. R tends to infinity means this energy tends to 0. 1 by infinity tends to 0. So we can easily say that in the final condition, the energy in the final condition, kinetic energy as well as potential energy, turns 0. See, this is the final condition. So you have to understand, this is the energy initial. The total energy initial should be equal to total energy final as per conservation of energy. This is a key concept in this derivation. Now, it's very easy. The rest of the task is, just, manipulation, just arranging the terms. Now we can see that. See, half VE square is equal to GMM by R. So we can cancel out this mass. So we have to isolate VE square from here. How much is VE square? VE square is going to be equal to 2GM by R. Okay. So V is going to be equal to under root 2GM by R. So this much velocity we have to give if you want to through some body to the outer space. So on the surface of Earth, we have to give at least 11.2. I hope all of you heard about that. Number. See, 11.2 kilometer per second, not per hour. This much velocity we have to provide. If you want to send some object to moon, or if you want to send some satellite to the outer space, we have to project the body with a minimum velocity of 11.2 kilometer per second. In 1 second, we have to cover 11.2 kilometer. So that is the idea. So this is the concept behind escape velocity. I hope all of you understood this. If you want to learn concepts through this kind of simple and lucid explanations, you can join UNS classes. We are providing online classes. We are providing for foundation classes for class 8, 9 and 10, and NEET and JEE or KVPY or ISER aptitude test coaching for +1 and +2 students. Thank you very much. You can subscribe this channel to get more updates like this, to get more videos like this. Thank you very much. See you soon with another video.